Okay, so the first question here is find the set of values of x for which 2x plus 1, x minus 1 are greater than 0. Okay, so basically you have to just find values of x that are going to hold this inequality true. Okay, so basically what's going to happen here is first you put here 2x plus 1. So basically each expression in the bracket you're going to equate to 0. So 2x plus 1 equals 0. And then here also x minus 1 equals 0. You solve for x. 2x. So this positive 1 goes over the equal sign, becomes negative 1. To get your value of x, you divide both sides by 2. So here we have x equals negative half on one side. Then on the other side, we solve also for x. So x equals, so the negative 1 crosses over the equal sign, and x equals 1. Now, we are going to, this x equals negative half and x equals 1, we'll make a number line like this. Because we want to find values from this number line which are going to hold the inequality true. Okay, so you put x equals negative half here, x equals 1 here, right? And then you bring both equations back here. This one, 2x plus 1 greater than 0 here. The x minus 1 greater than 0. So what's going to happen here, colleagues? We are going to pick values from this number line, and we're going to see which range of values hold this inequality true. Okay, so we start with negative half here. We can try any value which is less than negative half, and we try to put it into this equation, and we're going to see if it holds the inequality true. Okay, so negative 2, we can use negative 2 here. Okay, negative 2 here is less than half. We try to substitute it in this equation here. Okay, so we'll say 2x into, we substitute x with negative 2. Hello? Yes, we're on this number line part and want to find values which are going to hold the inequality true. This is what you have to put here. So 2x plus 1. Yeah. So on this number line, we're going to check for values to see whichever range of values hold the inequality true. So as I said, we start on the left side of negative half here. Okay, you can pick any number that is less than negative half and you put it back into the original equation and see if it holds the inequality true. If it holds the inequality true, then that range of values is part of the possible values of x. Okay, so we start with any number less than negative 2. So negative half. So as I said, let's try negative 2. Okay, so if we substitute negative 2 back into this expression here, 2 times negative 2 plus here where there's x, you substitute it with a negative 2, negative 2 minus 1. Want to see if this will hold the inequality true. So 2 times negative 2, that is negative 4. Negative 2 minus negative 1, negative 3. Negative 4 plus 1, that is negative 3. So negative 3 times negative 3, that is positive 9. Okay, and positive 9 is greater than 0. We can also try, so any value less than negative half is going to hold the inequality true. But you also want to find out, does also negative half, is it also part of that values that hold the inequality true? So you can also try negative half, put it into this equation here. 2 times negative half plus 1. Then here we have negative half plus 1. Here I'm just trying to see if negative half is also part of the values which of x which hold the inequality true. If it's not part, then we'll say any value of x that is less than negative half makes the inequality true. But if negative half is also part of it, then we'll include it in the values. So 2 times negative half, that is negative 1 plus 1. Negative half plus 1, that is half. Negative 1 plus 1, that is 0. 0 times half, 0 is not greater than 0. So any value of x, not including negative half, but any value of x that is less than half makes the inequality 0. So this is our first range of values. Any questions before we go to the next range? These workings, the trial and errors, you don't have to show them. Okay. The trial and error starts from here. So the trial and error you don't have to show them. Okay, because you'll be trying a lot. You just pick one value from each side and just say, okay, does it hold the inequality true? Yes. So these ones you don't have to show them, sir. They are part of your rough workings. So the next range of values, you're going to try are between negative half and 1. Mhm. Or negative half minus 1 here. Okay, so negative half minus 1, that's negative 3.5. Okay, so negative 3.5 times 0 is still 0. So we can still exclude negative half from this range. Okay, can exclude. If negative half was part of this range, you would have written it like this. It means, yeah, including negative half in the range. For any value of x which is negative half or less than negative half, it was inequality true. Yeah. Yes. So you try the next range now between negative half and 0. Which number can we pick, colleagues, between negative half and 1, which we can try to the inequality? We can try 0. Okay. If you try 0, if you substitute 0 back into this original inequality, 2 open brackets 0 plus 1, we just substituted 0 for x, 0 minus 1, 2 times 0, that is 0, 0 plus 1, that is 1, 0 minus negative 1, that is negative 1, negative 1 times 1, that is negative 1. So it does it. This is not true. Negative 1 is not greater than 0. So basically, this range from negative half and 1, there are no values of x, because if you choose any value from this range, it won't hold the inequality true. Okay, because this is the game that's happening here. We're just picking values from these ranges to see if the values we pick in that range, if they hold the inequality true. So this range between negative half and 1, it's not part, so we can ignore it. Then the next range is from 1 to infinity, 1 over to the right side. So we can start with 1 and say, okay, can 1 be included in this range? So you try x, you substitute x for 1 into this inequality here. So 2, where there's 1, x substitute with a 1, 2x plus 1. 1 minus 1. So 1 minus 1, that is 0. So whatever value we get here, when we multiply it by 0, 0 is not greater than 0, basically. Okay, so 1 is not going to be included in this range because it's not holding the inequality true. Okay. So now you try, okay, let me try another number from this range. Let's try positive 2. So you substitute it back into the inequality. Okay. This 6 marks is not for nothing. It's because of this trial and error that you'll be going through. Okay, so we're substituting for x for 2. Okay. 2 times 2, that is 4. 4 plus 2, that is 6. 2 minus 1, that is 1. 6 times 1, that is 6. 6 is greater than 0. So anything above 1 is going to hold the inequality true. So you say x. So for values of x greater than 1, they will hold the inequality true. So these are your answers here. For any value of x less than negative half and any value of x greater than 1, they are going to hold the inequality true. Any questions? So this is a recap of the steps. The first thing, solve both expressions in the bracket, solve them so that you can get your, basically this negative half and your 1, think of them as your critical values. Okay. They'll give you where the ranges start and start from, and where they'll divide the ranges, basically the ranges from where you're going to pick. So when we solved 2x plus 1, we got x equals negative half. When we solved x minus 1, x equals 1. So you make a number line with these two critical values, negative half and 1. Then within that number line, you now start selecting numbers from the 3 different ranges, because you'll be working with 3 ranges. Okay. So the first range we used was this range for x being less than negative half. And the values in this range, you substitute them into the inequality, it holds the inequality true. We tried the range between negative half and 1. The values in this range, they won't hold the inequality true. Then we tried this range of greater than 1, and we saw the values in this range also hold the inequality true. Okay. Yes. Any questions before we move to the next one? You find your 2 critical values first. So once you find your 2 critical values, then you know how the number line appears. So here, since we knew our critical value 1 was x equals negative half and x equals 1, so when we drew our number line, that's how we put them like this first. Does that answer your question, Mr. Foundation? In the workings? Yes, yes. You said something about, just ask your question again. You're saying that you won't show the arrows. I heard something about arrows also. Or these arrows which I'm showing here on the workings. They are not necessary. Me, the arrows I'm showing you the ranges where they are going to and from. So you don't really need to show the arrows. The marker already knows that, okay, you have your critical values, and then the arrows are just showing the range. Okay, so the range on the left hand side is from negative half to infinity. The range on the right hand side is from 1 to infinity. Then the range in the middle is between 1 and negative half. So you don't need to show them, sir. They're not necessary, okay? Yes. Then in your workings, you show in your workings that, okay, you pick a value and say, if we choose this, you pick the value and you should prove that it holds the inequality true. Okay, so for each range, just pick one value. So if you're picking negative 2 here, you say, okay, in your workings, you say, let x equal negative 2, and then you put it in the original expression and prove that that value holds the inequality true. Okay, then you know your ranges. And I also advise you use the actual critical values also, because sometimes the critical values can be included in the ranges. So in short, you're going to try how many values? One, two, three, four. You're going to try five values in total. Okay. Two of them are the critical values, then three values from the possible ranges that you've chosen. Okay, we have this next question here. Square root over 2x squared plus 7x plus 11 equals x plus 1. So the first thing that we need to do is we need to get rid of this square root sign. So how you get rid of the square root sign? You square left hand side and also the right hand side. Okay. And when we square, so the left hand side becomes 2x squared plus 7x plus 11. Colleagues, are we okay with how this has disappeared with this power 2? Are we okay with how that has disappeared? Do I need to go a bit deeper? No. Remember from indices, the root is the same as to the power half, right? So like the root is like to the power half. So, okay, so this is like to the power half. So when you square it, multiplying it by 2 here, half times 2, that is 1. So that's how this root has disappeared. Excuse me. That's how the root disappears. Then on the left hand side, you expand. X times x, x squared. X times 1, x. Then you say 1 times x, that is x. 1 times 1, that is 1. Okay. So this side, x plus x, on the right hand side becomes x squared plus 2x plus 1. Then now we need to bring everything on the left hand side, okay, so that we have a proper quadratic equation. Okay, so everything that's on the right hand side, we're taking it to the left hand side. So here we have 2x squared. Then this x squared from the left hand side, when it comes, it becomes minus x squared plus 7x. Then this plus 2x, when it comes, this side becomes minus 2x because they're grouping like terms together, plus 11. Then this one from there becomes minus 1 equal 0. Then you solve 2x squared minus x squared, that is x squared, plus 7x minus 2x, 5x, plus 11 minus 10, minus 1, that is 10. Okay. X squared plus 5x plus 10 equals 0. Okay. Next, now is is to solve the quadratic equation. Okay, so colleagues, what two factors of 10 are such that when you add them, when you add them, they should give you positive 5, and when you multiply them, they should give you 10. They are no. So you have to use now the quadratic equation. Yeah, yeah. Okay. When factorization fails, then you go to the quadratic equation now. You get the same answers. The, the equation is the most definite way. That's the factorization way. Factorization, not all quadratic equations can be factorized. Okay, not all quadratic equations can be factorized. So the equation is the one which is the one which always works, basically, or most of the times it works. So what is our B? What is our A? What is our C? B is the coefficient of X. Okay, so -5 plus minus -5. Oh, B is +5, so 5 squared minus 4 times. A is the coefficient of x squared, which is 1 in this case here. So 4 times 1. C is on this number without a letter in the quadratic equation, which is the constant. So C is 10 over 2 times A, and that is 1. So -5 plus or minus 5 squared, that is 25, minus 4 times 1 times 10, that is 40. Okay, so this quadratic equation doesn't have a real answer. 25 minus 40, you're going to get a negative number. Okay, now when you have a negative number in the square roots, it means you have imaginary numbers, basically. You don't even go ahead solving. You just say x has got no real roots. When you have a negative number in the square root here, 25 minus 40, that's -15. Okay. So if you try to put in your calculator square root of 15, try to put it in your calculator square root of 15, see what the calculator tells you. So you end there and you say x has no real roots, meaning this doesn't hold true, basic. So you end there, colleagues. There's no value of x basic. No, at other times, other times it can go through. Other times it can go through, sir. Other times it will. Okay. Ah, it's a lot of. Uh, and it's just that we met a bit late. We met a bit late. Yeah. I will start as early as possible. I'm telling you, because the thing is this. The courses are big. These courses are big. So it's yeah. We'll start early. It's just that we met each other this year. So it's at least we can be appreciative that at least we met each other. So that now this time in the coming future we'll do things early. Yes, you let me know whatever topics you have, so that okay. But those universities, mm, the way they name these courses, you find even topics which okay. Just from the name of the course, meaning the topics even switch. University, yeah, it's not standard that, but I'll have an idea. Once you tell me the course, I'll know the important topics to look at. Yeah, it would have been. I think that can even be better, so that everyone comes out qualified. Basic, yes, because some university. Mm.